Positron AI, a startup building purpose-built hardware for AI inference, just closed a $230 million Series B at a valuation of over $1 billion, backed by Arena, Jump Trading, Arm Holdings, and others. Today, we're talking with Cameron McCaskill, Head of Sales and Business Development, about the funding, the technology roadmap, and where the company is headed.
So the Series B was $230 million, which puts the company valuation just over $1 billion, which we're very excited about. Actually, that financing activity happened much sooner than we anticipated, and is a larger round than we anticipated. So in terms of the use of funds and how we would use that additional money, first is software hiring. Software is frankly always the toughest part for silicon companies to nail. And so we're doubling down on the software hiring just to be absolutely sure that we have the right number of resources to build that side of our business in addition to the silicon, which is already well staffed. And then the second area that I would say we will use the funds for is go-to-market acceleration. We have been incredibly thin by design in terms of our sales, technical support, marketing efforts. Been in near stealth mode really since we started the company 3 years ago. We've been shipping our first generation Atlas server for a year and a half, and I still get into a number of meetings and people haven't even heard who Positron AI is. So we've got to change that, and that will happen with the additional go-to-market funds. And then the third area I would say is we've purchased some additional emulation equipment at Positron. What that will allow us to do is de-risk the silicon tape out. We have a planned tape out for our Asimov chip late Q3, early Q4 of this year. And so doing more thorough emulation on that product de-risks the part quite a bit. And it also allows us to do software bring up on the emulation equipment ahead of actually getting silicon in-house.
Software, go-to-market, and silicon de-risking. And that last point leads us straight to the hardware. Context windows and model sizes are growing fast. How does 2 terabytes per chip and 8 terabytes per Titan server change what's possible for inference?
So the first thing to note is that the most direct attached memory that like a GPU type of architecture will have, and the time frame that we're launching our second generation Titan server. Titan server is the name of the server that the Asimov chip goes inside. The most memory that will be directly attached in that time frame for a GPU architecture is about 288 gig. By comparison, we'll have over 2 terabytes of direct attached memory to every chip. And so in a Titan server, we'll have over 8 terabytes of memory. So what does that allow you to do? First of all, the models are getting much, much larger. I mean, even open source frontier models today are in the 1 trillion plus parameter size in terms of the overall model size. And then secondly, the context lengths are increasing into the millions of tokens types of size. One of the key drivers of context length growth is like these software coding agents where you actually are iterating on a code base. And so the existing code base becomes your context that you need to feed into the model in order to iterate on that software code base and generate an even better output. And so the fact that we'll be able to store up to 16 trillion parameter models on a single one of our servers, single one of our Titan servers, and 10 million plus context length support, again, in that single server, just brings us into a realm that nobody else will be able to approach from a hardware development perspective. What you end up doing with a GPU architecture for these types of larger, multi-trillion parameter models or tens of millions of context length, et cetera, is you end up chunking the model into much smaller bite-sized pieces. And then when you finish the workload for the inference, you then have to reassemble it. Well, what that does is that increases complexity from a software perspective because you're having to break up the model and then reassemble it. But it also means that you have to spend a lot of money on networking to make sure that networking doesn't become the bottleneck between servers. If you can run that entire workload in one server, you don't have that networking cost and complexity and potential bottleneck, and you don't have the software complexity of having to break the model up and reassemble.
One server, no chunking, no networking bottleneck. A fundamentally different architecture, which raises an obvious question. How does a company balance shipping Atlas today while the next generation Asimov is still in development?
Asimov is our first custom silicon that we're developing. It will feed the second generation server. So we've been shipping our first generation Atlas server for about a year and a half now, so since August of 2024. From day one, our plan was to engage customers as soon in the process as possible. What you see from other AI chip companies is they don't truly engage customers, and by that I mean running real customer workloads, getting customers testing their software in production environments, etc. You don't get that direct feedback from customers and that engagement from customers until you get your custom silicon back, which for most AI chip companies, year 3 or year 4 before they've really engaged customers. We decided from day one as a company that we were going to do things differently, that we're going to actually build based on what's called an FPGA. Just think of it as a programmable chip. So we took an off-the-shelf programmable chip, programmed it to basically mimic what we're going to build in our ASIC, our custom silicon Asimov. And that way we know we're building the right chip. And we've actually engaged customers. We've run real customer workloads through it in a production environment. And that means that we've vetted the software, we've matured the software, and we understand how customers are going to use the system when we build our second generation Titan server.
Software vetted, customers on board, and the architecture proven in production. So with that foundation in place, what's the 3-year vision?
The inference market is by far the fastest growing part of the market. I think really the first 2 or 3 years after ChatGPT launched, a lot of the focus was on training these models. While training is certainly still a key focus area for the industry, the vast majority of the growth is on the inference side. That's once you've got a model that you're happy with and you're ready to put it into production, that's inference. And so where do I see Positron in 3 years? I see Positron within 3 years as the recognized leader in purpose-built AI inference hardware. And so what I mean by that is I think ultimately when a model or when a market starts to mature, you start to normalize around more common metrics in business. And so I think everything will get measured on performance per dollar and performance per watt. And that's how you will compare one inference solution against the next. And if we become the gold standard, which I believe we will within 3 years, then we're really the measure that everybody is comparing against in terms of inference, performance per dollar, and performance per watt.
Customers on board, a next generation architecture unlike anything on the market, and a roadmap that's only getting more ambitious. Positron AI is building fast and building different.